Hello everyone. In this lesson we're going to cover 19.3 day 1, and this is going to be throwing all of these sine, cosine, tangent graph together with horizontal shift. So we're going to cover everything we did in 19.1, and then also we're going to add the horizontal and vertical shifts. So the graphs are not only going to be just starting at 0, it could start from some point other than 0 because of the horizontal shifts and then vertical shifts. So hopefully you guys will get the hang of it after doing a few problems together. So day 1 involves graphing by translating the trigonometric graph. So let's take a look at the first slide here. So we have the general equation. So earlier in the previous lessons, you have learned that we use the general equation A times sine of 1 over bx only. Notice that the h and k were missing, MIA. And so now you will notice that there's h and there's k. Those are going to be indicating the translations. That's what's going to cause the translation to the left and to the right for the h, and then up or down by the k. So that's going to be the new item. Everything else should remain the same. As far as vertical stretch or compression for A, horizontal stretch or compression for B, everything else will stay the same. The only thing new is on top of that, the graph can shift to the left, to the right, or up and down. All right? And it's going to be the same thing for the cosine. So let's take a look at the first example. Example 1. The good thing is we're going to try to follow the same routine that we have established to graph. So we're going to follow the 5 steps, same thing. Okay, so let's review before we start. We already know that for the sine function, it goes the original period from 0 to 2 pi, and then it follows the snake model, right? So I think what's important for you to remember now is that the beginning point is at 0 and ending point for the original parent function is at 0 and 2 pi. So keep that in mind because we're going to need to find the new beginning and new points. So step 1, let's name the transformation. So we have a vertical stretch of 2. And then B is actually equal to 2. So that's a horizontal stretch of 2 as well. And on top of that, we have h. That means this is going to shift pi units to the right, and minus means to the right. Okay, guys, do not get confused. So it is to the right. So those are all the transformations. There is no k in the back, so no up or down. So this is all of the transformations. So we're still going to follow step 1, which is finding the amplitude. That's the absolute value of 2. At least we, following the routine to make you feel like, okay, I've done this before, right? So that's step 1. Step 2, period, is still going to be the same, 2 pi times b, and we know that b is actually 2 in this case, right? So it's going to be 2 pi times 2, which means 4 pi. Step 3 is the partition. It's still going to be the same thing. We're going to take 4 pi divided by 4, chop it in 4 parts, right? Remember, there are the 4 parts here. So we need to chop it up in 4, and it's going by pi. So we can count by pi, and we need to know where to start counting because we already been shifted pi unit to the right. That means this graph is thrown like off. It may start something like that now. It does not start at 0 anymore. So we need to know where is this point that we are starting and where is point that we are ending. So we need to know those 2 points, right? Where does it start now and where does it end? And that is why we need to map it up to the original graph that starts at 0 and 2 pi. So for this part, we're going to set everything that we see in the equation equal to 0 and 2 pi. So everything after the word sine, we're going to set that. So this will be kind of like, right after partition, we'll do that. So we're going to set that 1/2 times x minus pi equal to 0 because we want to know where does it start. Okay, so where does it start? The new beginning. And where does it end? Mapping it up, lining it up to the parent function. So setting the 1/2 times x minus pi equals to the original ending. Again, pay attention to that beginning and that ending. We're matching it up to that. So that way we can line it up and see where's the new beginning, where's the new ending. So first thing we do is multiply by 2 to get rid of that half. So I have x minus pi equal to 0 still. Adding pi to both sides, I have x is going to start at pi. And same thing here on the other side. X minus pi equals 4 pi. Adding pi, x is equal to 5 pi. Okay, so we're going in nice and even numbers. This is easy so far because we're going to start with counting right now. So far, the graph, it should be pretty easy. For the x-coordinate, we're going to start with pi. And we're counting by pi, guys. That means we're adding pi every single time. So add pi, that'll be 2 pi, 3 pi, 4 pi, and we end at 5 pi. See how perfectly it lines up? We start at the new place of pi. We end at the new place of 5 pi. For a period, total period is 4 pi, right? From pi to 5 pi, isn't that 4 pi period? Yes. So those are the new places of the x-coordinates that we have. As for the y value, we are still going to follow the same routine for sine. Remember, it starts with 0. So these are the original y values. Then we go to 1. Then we go back to 0. Then we go to -1. And then we come back to 0. So those are the y values. And we need the y equation. And basically, we read this whole thing with the sign as y. So it's 2y. And again, we don't need the x equation, but it would have been x plus pi. So we're going to multiply 2 by y. So that's 2 times 0, which is 0. And 2 times 1 is 2. And 0 again. And -2 and 0. So the last step is we are going to actually graph this. I'm going to try to squeeze it over here. And we know that we are starting at pi. So I'm just going to go pi, 2 pi, 3 pi, 4 pi, and 5 pi. So 1 at each place. So at pi, it's going to be 0. So I'm going to just make this 1, -1, 2, -2. So at pi, it's going to be 0. Let me change the color. So we have pi 0. That's the beginning. And then 2 pi at 2. Then 3 pi at 0 again. Then 4 pi at -2. And 5 pi is at 0. And if I connect those dots, I will have the new graph. So notice that this graph is totally thrown off. It doesn't start with 0 anymore. It's shifted pi units to the right-hand side. So it starts from pi, it ends at 5 pi, and that's the new graph. And this graph has been stretched vertically by a factor of 2, horizontally stretched by a factor of 2, and shifted pi units to the right. And that is basically how we graph an equation that has horizontal movement. And we're going to get into one that has vertical movements right now. So let's take a look at the next example. All right, so this graph, as you can see, this equation involves a number. So we can see that there's going to be h and there's going to be a k because there's a number in the back. So let's start with the transformation. We have a vertical stretch of 3. We don't have any horizontal because this number in front of the parentheses is just 1. So we have pi units to the left because it's plus, so it's opposite, okay? And then we have 1 unit up. Those are the transformations. So let's start with step 1. Amplitude is equal to 3. And step 2, period equals 2 pi times b. And we know that b is equal to 1 because it's 1 over 1. That's going to give me a 1, right? So b is just 1. That's nice. And that means the period does not change. It is staying at 2 pi. Wow. Step 3 is the partition. And we're taking 2 pi divided by 4, which gives me pi over 2. That's the original cut. Okay. Step 4, I'm going to do the cut now for the x. X is going to, well, I need to know, before I start to step 4, I need to know where does the graph, the new beginning, and where does it, the new ending. So I'm going to set this inside right here, everything after the word sign, but you don't need k, only whatever h is involved, okay? And so I'm going to set the start, excuse me, I'm going to line up x plus pi. Remember, original start and original end. And so x plus pi equals 2 pi. So the original beginning is at 0, original ending is 2 pi. So you always set it equal to those two for sine and cosine. And so solving for pi, x, I'm going to get negative pi. And then solving for x again, pi. So we're going from negative pi to pi now. And that's the 2 pi period, isn't it? So that actually matches the pi. So we're going by half a pi. And if you're weak with your fractions, again, instead of counting by half a pi, you can go half. You can go with 0.5. So the equation would have been x, we're going to the left, right? So it would have been minus pi. So we're starting at negative pi, which is right here, and then going by half a pi. So you can go negative pi over 2 or 0.5 pi, and then you're going to end up at 0, and then you're going to end up at pi over 2, and then you're going to end up at pi. So those are the 5 points. For the y value for sine again, remember following this, it would be at 0, 1, 0, negative 1, and 0. And the y equation, you can tell that it's 3y plus 1. So we're going to do the math. So 3 times y plus 1, that's 0 plus 1, that's 1. 3 times 1 is 3 plus 1 is 4. 1 again. 3 times negative 1, that's negative 3 plus 1, negative 2. And then 1 again. Last thing I'm going to do is draw the graph. So my partitions, I could have started it earlier already with my partition. I'm going to start with pi, guys, but I'm counting by half pi unit. So here's my 5 points. So that's negative pi over 2, 0, pi over 2, and pi. That's the beginning. I'm starting here, and I'm ending here. So the coordinates for the amplitude is, I need to make little marks here so I know where to go. So at pi, negative pi is at 1. There it is. I should use another color. So at negative pi, it is 1. At negative pi over 2 is 4. And then at 0, it's 1. At pi over 2 is negative 2. And then at pi, it is back at 1. And so this is the new graph. There is one thing that we should actually mention here is that notice there is a line in the middle right here. This line is called the midline. And we're going to get into more details about that and another example. Midline is what cuts the graph into 2 equal parts. So notice there's an equal amount of space on top and bottom. So notice that from the maximum of 5, by the way, I'm sorry, not 5, 4. This is the maximum, and this is the minimum. From the maximum to the midline, and by the way, this midline is always defined by the number in the back. So that's 1. So this is the equation y equals 1. That is the midline. So from 1 to 4, so here's 4, here's 1, there's a 3 unit, correct? And from 1 to the minimum of negative 2, there's also 3 units here. And guess what 3 is equal to? The amplitude. So it all makes sense. So the amplitude is 3, right? So that's why that 3 plays an important part. And so that's why that is the interesting about the midline. So I just wanted to let you know that because we're going to go into more details. And that is the final graph with 1 full period. And here's another example. So this one is involving cosine. And notice that the transformation is that it has a vertical stretch of 3. There's also a horizontal stretch of 2. And then pi units to the left. Those are the transformations. Step 1, we're going to find the amplitude, which is absolute value of 3, which is 3. And by the way, that amplitude, you don't really need to take the absolute value unless it's a negative in front, like, if it's negative 3. So we just do it anyway. It doesn't really matter. So the period equals 2 pi times b, which means it's 2 pi times 2, which gives us 4 pi. So the period is 4 pi. And so step 3 is the partition. So hopefully by now we're doing the same steps over and over and over. You're getting the hang of it. and it's getting easier for you. 4 pi divided by 4, always the partition you divide by 4, because that is the number of parts the graph has, and that is counting by pi again. That's an easy one. Now we need to know where do we start lining up. So here we got this whole thing. We're going to set it equal to 0. And where does it end? We're going to set the whole thing equal to 2 pi. So we're setting it equal to 0. Remember, the new original is starting at 0 and ending at 2 pi. So we're going to set that equal. And so to solve for it, times 2 on both sides, I have x plus pi equals 0 and x equals negative pi. And then same thing here, we have times 2 is going to give me x plus pi equals 4 pi. Subtract pi, I have x equals 3 pi. So I'm going from negative pi to 3 pi. That's for a full 4 pi period. So here's the new beginning and new ending. If it makes easier for you, you can go ahead and start drawing already. You're counting by pi. So you can just draw your marks by pi. So here's negative pi. That's 0, 1, 2, 3. So here's where the ending is. So starting at negative pi, ending at 3 pi with 5 marks over there. And so the step 4 is the table. So the partition is you starting at negative pi, you're going by pi. So that's 0, pi, 2 pi, and 3 pi. So you end at 3 pi. So here's pi and 2 pi. And then for the y value, it's just 3y. And the equation for the x is x minus pi. And for the y values, for the cosine, remember, it's following this pattern. So you start at the maximum, you go to 0, you go to the minimum, you go back to 0, and you go back to maximum. So multiplying everything by 3, you got 3, 0, negative 3, 0, and 3. And so the graph is going to be at, notice this is the minimum, and we have 2 maximum locals, local minimum and local maximum. So at negative pi, it is 3. Let me change color. Negative pi is 3, and at 0, it is 0. At pi, it is negative 3, and then 2 pi, it is 0, and 3 pi, it is 3. Yay! This is what the graph looks like. And that is step 5, end of the problem. And I believe it is time for you to try one because I have done quite a few of these. So you can go ahead and pause the video and try it on your own before you look at the answers because it will help you to practice first. Hopefully you've had a chance to try the problem. So let's go ahead and label, start with the transformation. So it's a vertical stretch of 2. There's also a horizontal stretch of 2, and then pi over 2 units to the right. Those are all of the transformation. Step 1, the amplitude is absolute value of 2, which is 2. Step 2, period equals 2 pi b, which is 2 pi times 2, that's 4 pi. The partition, step 3, is going to be 4 pi over 4, which is going to be pi. You're counting by pi. And let's see, where do we start and where do we end? So we're going to match up everything here. 1/2 times x minus pi over 2. Set it equal to 0. And for the end, we are also going to set the same thing equal to 2 pi because that is what the original starting and ending points equal to, right? So solving by multiplying by 2, x minus pi over 2 equal to 0, adding pi over 2, so I have pi over 2, times 2 here is going to give me 4 pi on the right hand side, and then I'm going to add pi over 2. So I have x is equal to 4.5 pi, and that is basically 9 pi over 2, or 4.5 pi, if it helps you easier. This is like 0.5 pi. So the new beginning is going to be at 1/2 pi and ends at 4.5 pi. So if you want to like start it, you can go ahead and do. So you can go 1, 2, 3, 4, 5. So these are halves. These are pi's, okay? So we can go by pi. 1/2 pi is the beginning. So we're going to have a new, let me use another color so you know where the marks are. So that's 1. And then we're counting by pi. So that's half, 1.5, 2.5, 3.5, 4.5. Those are the marks. And then for our table, for step 4, the partition is going to be starting at, remember, 0.5. And we're adding by 1 pi, right? So 1.5 pi, 2.5 pi, 3.5 pi, and ending at 4.5 pi, which is 9/2. And then this is a cosine, so once again, it's following maximum, 0, minimum, 0, and maximum. And so we're going to do the math. So this is 2y, the equation. It's 2y. And the x is x plus pi/2 because we're moving to the right. Now, for the 2y, we're going to multiply by the y values by 2. So it's 2, 0, -2, 0, and 2. So here's 1, 2. And let's go ahead and graph this. And so at half a pi, it is at 2. At 1.5 pi, it is 0. At 2.5, it's -2. At 3.5, it's back to 0. And 4.5 is at 2. And there is our final graph. And the graph, notice, is vertically stretched by a factor of 2, horizontally stretched by a factor of 2. And it got shifted pi/2 units to the right, and that's pi/2 right there. Okay, so that is the end of this problem and also the end of this lesson. Go ahead and get started with your assignment. Have a nice day.